Have you ever wondered how a political poll can call an election by talking to just a few thousand people? Or how a factory knows a million light bulbs are good without testing every single one? It kind of feels like a magic trick, right? But it's not. It's the key to how we understand our world. So today, on The Explainer, we're going to pull back the curtain on the powerful idea that lets us know about the whole just by looking at a tiny part.
I mean, think about it on a simpler level. You'd never cook an entire huge bag of rice just to see if it's any good. Of course not. You grab a few grains, you cook them up, and you trust that little handful tells you the story of the whole bag. Well, that simple gut feeling, that's actually statistics in action, and it's way more powerful than you might think.
And this same logic is everywhere. How on earth do you test the lifespan of a fluorescent tube if the test itself, well, destroys the tube? How do you figure out the morale of a 30,000-person company without bringing all work to a grinding halt for a week, or know if your new product is going to be a hit? In all of these situations, checking every single item is either impossible, way too expensive, or just completely impractical.
So, what's the solution to all these puzzles? It's a really powerful idea called sampling. Simply put, it's the art and the science of understanding a huge group by studying a small, very carefully chosen piece of it. It's the smart shortcut that makes so much of modern life, from industry to science, even possible.
Okay, so to really get this, we need to get two key terms straight. First, you have the population. That's the entire group we're curious about. All 30,000 employees, every single light bulb that came off the assembly line, the whole shebang. Then you have the sample. That's the small, manageable group we actually study, the 250 people who get the survey. The whole trick, the real magic, is making sure that small sample is a perfect little mirror of the entire population.
So, the million-dollar question is, how do we actually choose that sample? Well, it turns out there are two completely different ways of thinking about it, two different paths you can take. And it all comes down to a fundamental choice. Are you going to rely on pure random chance? Or are you going to rely on human choice and judgment?
The first path is probability sampling. Think of this as the scientific, by-the-book approach. Here, every single person or item has a known shot at being picked. It's governed by the rules of randomness, kind of like a lottery. The other path is non-probability sampling. This is totally different. It relies on what's convenient or what an expert thinks is best. The selection isn't random at all. It's based on who's easy to find or who someone decides should be included.
So, let's start with that first toolkit, the rules of chance. These are the precision methods. You use these when you need to be really confident in your results, when you need something scientifically sound. We're stepping into the world of probability.
The purest form, the absolute gold standard in this toolkit, is simple random sampling. Now there's a subtle but really crucial point here. It doesn't just mean every person has an equal chance of being picked. It means that every possible group of, say, 100 people has the exact same chance of being chosen as any other possible group of 100. That is true, unbiased randomness.
So how does this actually work in the real world? Conceptually, it's a three-step process. First, you need a complete list of everyone in the group. Statisticians call this a sampling frame. Second, you assign every single person a unique number. And finally, you just let a random number generator pick the winners. It's basically the high-tech version of drawing names out of a hat.
Now, making a true random sample can be a lot of work. A much more practical shortcut is systematic sampling. You randomly pick a starting point on your list, and then you just select every kth person after that. So every 10th person, every 50th person, whatever you decide. It's way simpler, but, and this is a big but, you have to make sure there isn't some hidden pattern in your list. If every 10th person on your employee list happens to be a manager, your sample is going to be seriously skewed.
But let's be honest, populations are rarely just big uniform blobs. They usually have distinct layers, right? Kind of like a layer cake. And that's where stratified sampling is just brilliant. First, you slice the population into meaningful, similar layers called strata, say by income level or by job title. Then, you take a separate, random sample from inside each and every one of those layers.
The most common way to do this is proportional sampling. The logic is super straightforward. If the low-income group makes up half of the total population, well then, they're going to make up half of your final sample. Each group is represented exactly according to its size in the real world.
It guarantees your sample is a perfect little miniature of the population structure.
But we can get even smarter than that with disproportional sampling. Take a look at the variance column. This just tells us how diverse the opinions are within each group. So if you know one group has opinions all over the map, that's high variance, while another group thinks very similarly, that's low variance, it's way more efficient to sample more people from the diverse group and fewer from the uniform one. You strategically focus your energy where there's the most variety.
Now, it's really easy to get this next one confused with what we just talked about. This is cluster sampling. Here, you also divide the population into groups, but the groups, the clusters, are like diverse mini-populations all by themselves. Think of city blocks. Instead of sampling a few people from every single block, you randomly pick a few entire blocks, and then you survey everyone who lives on them. This is fantastic for saving travel time and money, even if it's generally a little less statistically precise.
Okay, let's switch toolkits. What happens when you don't have a perfect list of everybody, or you just need answers like right now? That's when you turn to the Expert Choice Toolkit. These methods are all about speed, practicality, and convenience.
The most basic method here is convenience sampling, and it is exactly what it sounds like. You sample whoever is easiest to get a hold of. Think about interviewing shoppers at just one mall or polling your friends on social media. It's incredibly fast, it's cheap, but the risk of bias is massive. The people you conveniently found are almost certainly not representative of the whole population.
So, to add a bit more control, researchers often use quota sampling. You can think of it as the non-random cousin of stratified sampling. You still want your sample to match the population on some important characteristics, so you set these specific targets or quotas that you have to fill.
For example, you might set a rule that says, my final sample must be 50% low income, 30% middle income, and 20% high income. Then you just go out and find people, often through convenience, until you hit those numbers. It forces the sample to be more representative, but, and this is key, the specific people who fill those slots are still chosen based on convenience, not by random chance.
So, we've covered how to sample, but that leaves one giant question hanging in the air, doesn't it? How many people or items do you actually need in your sample? Is 10 enough? Is 10,000 necessary? What's the right number? Well, the right answer isn't a single number, it's always a trade-off, and it pretty much boils down to three things. First, variability. The more diverse and spread out the group is, the bigger the sample you're going to need to capture that. Second, confidence. How sure do you need to be? A life-saving drug trial needs way more certainty and a larger sample than a quick opinion poll. And third, the inescapable reality of cost. Your budget and your deadline almost always place the final limit on how big you can go.
So now you have the toolkit. The next time you see a headline about a poll, a new study, or a product test, you can look right past the results and ask the most important question of all. How did they choose their sample? Was it the rigorous path of chance or the practical path of choice? Because understanding how they chose tells you everything about how much you should or shouldn't trust what they found. Thanks for joining us on The Explainer.